How's it going, guys? So for the Module 1 test review video, I'm just going to go over the Module 1, just the test review that we gave you in class today. I'm just going to go over that. All right, if you want to see any homework problems, I have 2 videos that go over every section's homework pretty much. Most problems in it, you should still go over them. I'm going to say the same thing I say every video. All right, sorry about the bell, but I'm going to say the same thing I say every video. Do not just watch my videos. Watch this as kind of extra stuff to kind of brush up on, but still go through your notes, go through your homework. If there's some type of problem I didn't go over in the videos, you should go over that as well, because it still has a chance to be on the test or the quiz. All right, well, I guess in this case, the test. All right, anyway, let's just get started. So convert the following from interval notation to set notation. So remember, if I want to list out what each set notation is, interval has the parentheses or the brackets. That's an ugly bracket. Inequalities that has the greater than, less than, greater than or equal to, or less than or equal to, and greater than or equal to. And then set, that's for the fancy brackets, right? So if I want to convert this notation to set notation, all I'm going to do is just write it like this, add the fancy brackets, and I want to write this as an inequality. So I'll say x is less than or equal to 7 for that first one. I'll put the big U for or. And the second inequality is from 2 to infinity. So I can write x is greater than or equal to 2. And just close it with these fancy brackets, which just stands for set. So I have the set of all x such that x is less than or equal to 7 or x is greater than or equal to 2. That's exactly what we wrote in interval notation. That's number 1. Number 2, solve for x and write your answer in interval notation. So remember, the notation matters. If we tell you to write it a certain way, you have to write it that way. So this is an and statement. So remember, that's talking about the overlaps. So I'm going to solve each one by itself. I have 11 plus 4x is greater than or equal to 19. 4x is greater than or equal to, subtract the 11, gives you 8. X is greater than or equal to 2. For the other one, I have 47 is greater than 5 minus 6x. Subtract the 5, 42 is greater than negative 6x. And when you divide each side by negative 6, you get negative 7, but it's now a less than x. Anytime you divide or multiply by a negative, the inequality is going to flip. So now I have x is greater than negative 7. So I'm going to draw a number line because I want to see, where are we overlapping, what's happening. I have negative 7, but negative 7 right there, the 2 right there. And for x is greater than or equal to 2, right, I'm going to draw above the line before I draw my final answer. I have that red line. And then for x is greater than negative 7, I have this line. So remember, when it comes to and, what you're looking for is where do they overlap. That's what I'm looking for, because for ands, you write that here, and where they overlap, that's your answer. Because I need both of them to be true. I need all the x's bigger than negative 7 and bigger than 2, or bigger than or equal to 2. So what I'm looking for is where they overlap. So if I look at this line right here, if I put them on top of each other like that, they overlap from 2 to infinity, and that's actually my answer. Every single x value from 2 to infinity is an x value bigger than 2, bigger than or equal to 2, and bigger than negative 7, right? So that's why my answer is x is greater than or equal to positive 2. And they want it in interval notation, so we'll write 2 to infinity. Remember, interval notation, really what it is you write where do you start, which in this case is 2. Where do you end? Well, I'm never ending, I'm going all the way to infinity. You write your endpoints pretty much, and then put a bracket or parentheses depending on what you have. All right, That's number 1 and 2. Let's keep going. Number 3, draw a sketch of a graph that has a domain of all real numbers. So I'm going to write everything that I want. Domain of all real numbers. So let the domain to be all real numbers. A range of -2 to infinity. In the following m behaviors as x goes to infinity. That's what increase without bound means. It means it increases without anything bounding it or anything stopping it. So as x goes to infinity is number 3. F of x goes to -2. And then 4, my second m behavior as x goes to -infinity. F of x goes to +infinity. So that's what I want. These are the 4 things that I want. I want my domain to be all real numbers. My range, I only want it from -2 to infinity. And for 3 and 4, I want my m behaviors to be as x goes to infinity, y goes to -2. As x goes to -infinity, y goes to infinity. So honestly, you can start anywhere for this problem. You can go one by one. So I want my domain to be all real numbers. So that tells me I want to make sure I have something for every single x. For the range, I want from -2 to infinity. So I know at -2 is a really small graph. I'll do a different color. At -2, I know I have to have an empty circle or something like that so that I don't, what's it called? I never equal it, right? I want to go from -2 up to infinity. So that green circle that I'm drawing, that is the smallest I can be, and I want everything above it. All right, so I hit my range for right now. After that, I'm told as x goes to infinity, I want my f of x's to go to -2. So at this point, we haven't really gone over this, so I wouldn't worry about this too much. But because I cannot equal -2 for my range, I will do this problem first. Since I cannot equal -2 for my range, right? I cannot equal -2 for y, I mean. And my m behavior is that as x goes to infinity, the y is going to -2. My m behavior this way is going to go down like this. That's because I know as x is going to infinity, positive infinity, the f of x's have to get closer and closer to -2, but never actually equal. All right, so that's what it would look like. I'm actually going to change this problem because we haven't talked about asymptotes. We're not going to test you on asymptotes because we haven't really gone over them. So I'm going to change this problem, in my case, to a bracket, just so you don't have to deal with asymptotes. All right, so I can equal -2. So now my new m behavior that I'm doing here is going to be a little different. I'm changing it just so it's a little easier to see. My m behavior is x goes to infinity. My y's are going to -2 straight, right? That's why I'm getting rid of the, I'm changing it to a parentheses to a bracket. I'm changing it not because the problem is wrong, just so we don't deal with asymptotes, which we haven't talked about in class, so we're not going to put it on the test. All right, no asymptotes there. So as x goes to infinity, the y's are going -2. So I did this one as well. And as x goes to -infinity, the f of x's go to infinity. So I just have to increase forever that way. That's pretty much the simplest one I can think of to draw. I hit all 4, what's it called? All 4 properties that I wanted. I have a domain of all real numbers. I'm going up to the left forever, right, and going to the right forever. My range goes from -2 up to infinity. I changed it to an inclusive because I don't want to deal with asymptotes when we haven't talked about it in class. 3, as x goes to infinity, my y's or my f of x's go to -2. I can see that on the right side. As my x's keep getting bigger, my y's are going to -2. And for number 4, as x goes to -infinity, my y's are going to +infinity. All right, just keep going. Number 4, find the inverse of f and its domain. If f of x is a minus 5x, is restricted to a domain of -3, 4. So there's 2 parts to this problem. The first, to find the inverse function, which we'll do first. The second, find out its domain if the original function has a domain of -3, 4. So let's do the first part first. I'm going to find the inverse function. So I'm given f of x is 8 minus 5x. Well, that's the same as y equals 8 minus 5x, right? F of x's are kind of like your y's. So y equals 8 minus 5x. And then to figure out my inverse, you flip the x's and y's. There's no real math here, just switch them. And then solve for y. Subtract the 8. X minus 8 is negative 5y. Divide by negative 5. X minus 8. All divided by negative 5 is y. And that's the same thing as negative 1/5 x plus 8 over 5. Right, just distribute that negative 5 to both the x and the 8. And that gives you y, which is also just the inverse function. Right, so that's what it'll be. Negative 1/5 x plus 8 over 5 equals f inverse of x. You can rearrange it if you want to. It doesn't really matter. That's your answer. All right. And now the second part, I need the domain of the inverse if the original has a domain of negative 3, 4. So this stuff trying to go between the domain of the original to the domain of the inverse can be a little confusing. So what I would do, or what I'll suggest, is make a table, like a little mini table like this. So for f of x, I know the domain. The domain is negative 3, 4. I'm given that. But I don't know the range. For the inverse, well, what I want is the domain, right? The problem is asking me the domain of the inverse. Find f inverse and its domain. So this right here, that's what I want. And I don't know anything about it. I don't know its range either. So I'll make a table like this and then try to work your way to what you want. I'm actually going to do it in a different color. What I want is this in green. That's what I want. So you work with what you have and try to see, well, how can I get to where I want? So I know that the domain of the original, that's the range of the inverse. Negative 3, 4. So the 4 should be a bracket. Right, I know that. So I have two ways to figure out that domain. I could take that range of negative 3, 4 I have here, and I could plug this in as y for the inverse function, right? Because remember, your ranges, what they are, they're y's. Your domain are your x's, right? That's what they are. Domains are x's, ranges are y's. I could plug in that negative 3, 4 range into the inverse function, into here for y, and solve for x. That will give me my domain, and that will work. And you can do that. It's nothing wrong with it. What I'm going to do, because I think it's a little easier, is I'm going to take the x's for f of x, right, this negative 3, 4. I'm going to figure out the range of f of x, because the range of f of x, well, that is the domain of the inverse, right? So it doesn't matter. They're all interconnected in this way, so it's up to you how you want to go about it. I'm going to figure out the range of the original, which is the domain of the inverse, right? So it doesn't matter. You can go either way, you'll get the right answer. So what I'm going to do, I know f of x is 8 minus 5x. I'm going to figure out, well, what's f of negative 3? That gives me 8 minus 5 times negative 3, or 8 plus 15, which is 23. So like I said before, and you saw this on the 1.3, 1.4 quiz, that the order of the parentheses in the bracket, it can flip. Right now I have parentheses negative 4, bracket 4. I'm sorry, parentheses negative 3, bracket 4. And it could flip because what happens is that the parentheses or the bracket, it follows the number. Negative 3 has a parentheses, 23 is going to get a parentheses. And now I'm going to figure out what is f of 4. 8 minus 5 times 4, or 8 minus 20 is negative 12. That gets a bracket. 4 had a bracket, negative 12 gets a bracket. And now you order it from least to greatest, right? It's always least to greatest. So I can say that my range of f of x is from bracket negative 12 to parentheses 23. And that also becomes the domain of the inverse because it's the same thing, right? So my answer is bracket negative 12, parentheses 23. And you see how the bracket and the parentheses switch? And that's because the bracket follows the bracket, the parentheses follows the parentheses. 4 had a bracket, well, 4 gave me negative 12, so negative 12 gets a bracket. Same thing with the negative 3. It follows the number that it came from. And that's your answer. All right, let's keep going. Number 5, the graph of f of x and g of x are shown. So looks like we didn't label this part, but this is f of x here. Find all values that satisfy each of the following. So f inverse of -1. So if I have f of x, that -1 is the y of f. So if I go to -1, I'll do this in red. Right, this -1 is the y. If I go to -1 and I draw a line all the way across and I follow this f of x, I cross it here and right there, which is what? 2, 4, 6, -7, and at 7. That graph is really, really small, but -7 and 7. And now this one in green, g inverse of 4, well, that's the same thing, just the other graph. I'm going to go to 4, draw a line, and see where do I cross g of x. So look here, I'm only crossing at -3. Right, x value of -3 is where I cross. And now I want g inverse of 1 and the f of that. So anytime you have a function inside of another function, work from the inside going out. So I'm going to figure out what is g inverse of 1 first. So g inverse of 1, if I go to 1 and draw a line, I cross only at that point right there at -4. So g inverse of 1 is -4. So this problem is now, what is f of -4? Well, f of -4 is right there. We'll say about -6. We'll say it crosses at -6. All right, so f of -4 is -6, and that is your answer. All right, and that's how you do that. Very similar to what you had on the quiz. That's your answer. Number 6. So for this one, we are told write an equation for g of x in terms of f of x in the graph of f of x. If the graph of f of x is reflected across the y-axis, then vertically compressed by a factor of 2/3. Before it is translated 4 units left results in the graph of g of x. All right. So basically what it's saying is that I want to figure out what's the equation of g of x if I have some function f of x and I'm told it got reflected across the y-axis. You want to do everything in order, and this problem doesn't matter too much, but in future lessons it will matter. So do everything in order at f of x. If I'm reflected across the y-axis, that is a horizontal reflection. That means that I now have f of -x. Right? It's a horizontal reflection. That means your b is -1. We reflect it across the y-axis. Then I'm vertically compressed by a factor of 2/3. So after that, I compress the whole function by -x by 2/3. So now I have 2/3 f of -x. And now the last part, the blue, is translated 4 units to the left. 4 units to the left, that means your h is -3. So what that means is I have 2/3 f of -x. And then from there, when I have this, I translated 3 units to the left. Sorry, 4. Where did I get 3 from? 4 units to the left. So when you go 4 to the left, what I'm going to do is I'm going to put a -4, right? Because x minus h, like that. The b's by itself, already applied it, and then I put the -4. That is a lot of parentheses, but we can simplify this down to say 2/3. Let's actually keep the color consistent. It should be -4 here, because remember it's x minus h inside the problem. So when you simplify this down, 2/3 f of -x plus 4. And that's what you get, because remember the equation is that g of x is a f of 1 over b, x minus h, all plus k. So you have an h of -4, you have x minus that -4. And that's why I put it like this, kind of see what's happening. And you get your final answer to be like this. Just write that equals g of x. Preferably write it before it, but whatever. And that's your answer. All right, number 7, f of x equals 2 minus 5 over 3x restricted to a domain of -3,9. Find the inverse and its domain using interval notation. All right, so it's very similar to a previous problem. We have 2 parts. Find the inverse function. We'll do that first. I'm not going to spend too much time because we did a problem just like this just a little bit ago. So find the inverse. Y equals 2 minus 5 over 3x. Flip them. Solve for y. We're going to multiply by the reciprocal. Because when you do, you have -3x over 5 plus 6 over 5. I'm distributing it. You don't have to. I normally don't. But why not? That's what you get. And then just write the inverse of x to make it, official, I guess. I don't know what word to use. Doesn't matter. Just write inverse, because that's like the proper way to say it. There is your inverse function. All right. Now, what I need to do for this problem is I need to find the domain of the inverse. Find the domain of the inverse using interval notation if the original f of x is restricted to a domain of -3,9. So I think it's actually exactly like we did before, right? Yeah, we're given the domain. It's pretty much the exact same problem. So honestly, if I was you guys, pause the video and try to figure it out. But I'm going to keep going to solve it. And remember what I said before. Make a chart, like a little table like this, to kind of see where am I going, what do I want. I'm given a domain of -3,9. And what I want, again, I'm going to do in green, is the domain of the inverse. So I want the domain of the inverse, but what I have is the domain of f of x. Again, there's 2 ways. Because the domain of f of x is the range of the inverse, you could just plug in -3,9 as y's into the inverse and solve it that way. I'm not going to do it. I think it's a little easier going this way. It doesn't matter, though. It's not like one's that much harder than the other. It doesn't really matter. I just prefer plugging in x's. So I'm going to figure out what is f of -3. That's 2 minus 5 over 3 times -3. Well, this -3 and that -3 cancel out. We're left with 2 plus 5, which is 7. -3 has a bracket. 7 gets a bracket. Now f of 9 is 2 minus 5 over 3 times 9. These cancel out to 1 and 3. 2 minus 15 is -13. 9 had a parentheses. Then -13 is a parentheses. You order it from least to greatest. So I have the range to be parentheses -13, comma 7 with a bracket. And then from there, because the range of f of x is the domain of the inverse, remember x's and y's flip, I can move this right over here to get my final answer of -13/7. And that's how you do that. Very similar to problem, I think it was like 4 or something, I forgot what it was. Very similar, same type of problems, different numbers. Let's keep going. So draw a sketch of a continuous graph whose only intercepts are -4, 0, 0, -3, and 2, 0, has a range of -5 inclusive to infinity, a domain of all real numbers, and a relative minimum of 5, 2. A lot going on. Let's list them all out. Continuous. For it to be continuous just means never be able to draw the whole thing without picking up your pen, right? There's no jumps to the x's, whose only intercepts are -4, 0. So I have to have these points, and these are the only intercepts I can have. So when we say that, that means you cannot cross the x-axis other than these points. I have a range of -5 to infinity, and I have a relative minimum at 5, 2. So 5, 2 is a minimum. So that's my things. That's what I have. That's what I'm going to do. So I'm going to go ahead and graph my intercept because I know I have to have these points. -4, 0, 0, -3, and 2, 0. These are the only intercepts I can have. So I plotted these. Make sure you do not cross the x-axis any other time. Also, a range of -5 to infinity. So my lowest point has to be -5. So somehow I have to get down to here somewhere on this line. And also at 5, 2, I have the minimum. I'm going to put a dot there so I don't forget about it. All right, I'm not told anything else. Oh, no, I am actually, sorry. Domain of all real numbers. That's actually pretty important. Domain of all reals. All right, so domain of all reals, that actually makes this a little easier for me. I know I have to start from the way left. I have to go up this way, go through this point, that point. That's a minimum. Well, I forgot you go down to -5 though. So I have intercept right there. I'm going to go down 0, -3. All right, we're going to go through that y-intercept. I'm going to hit that minimum, go back up. Let me redraw that a little nicer. Okay, there, -3. I have to go down -5, and I also have an intercept at 2, 0. It's kind of hard to draw because it's a really small graph. I'm going to go down. I'm going to hit -5, go back up. At 5, 2, I have the minimum, so I have to decrease to it and go back up. I think the key does not have at 5, 2 a minimum, a relative minimum. It didn't decrease and go back up. So the key is wrong for this problem. This is the right one. This has a domain of all reals. I'm good there. A 5, 2 minimum, I have that. A range, which is kind of hard to draw because the graph is kind of small for me, but -5 to infinity, including it. So I went down, touched the -5, went back up. All my intercepts, it is continuous, there's no jumps. All right, if you're having trouble with these graphing problems, there's multiple ones on the homework. Make sure you do those, make sure you understand them. There are some hard ones there. I would recommend doing them, at least looking at them, because I think the ones in review are a little easy. But I can think of one on the homework that's pretty hard. Just, if you're having trouble with these, at least go back and look at it again, try it again. All right, number 9. Find f of x and its domain. F inverse of x, and its domain if the inverse of x equals 5 minus 2x, and is restricted to the domain of -2, 7. So this might seem like it's different than the other two problems we did, number 7, I think number 4. It might seem different because you want to find f of x given the inverse, but it's really not any different. And the reason why is because f of x and f inverse of x, they're inverses of each other. It doesn't actually matter what you label them. They're inverses of each other. It doesn't matter. I could change the name and say find the inverse of x if f of x equals that. And that would not change the problem. All we change was the notation, right? Because they're both inverses of each other. So it doesn't actually matter what you call them. It's this notation. So it's the exact same thing as 4 and 7. Just because we called it something different does not mean it is anything different. They're inverses means they're inverses no matter what you call it. Call it a triangle and a circle. Like triangle equals this, circle equals that equation. It doesn't matter. It's notation. It doesn't mean anything. So with that said, the inverse is 5 minus 2x. So to solve it, just like always, y equals 5 minus 2x. Flip it. Solve for y. I'm not going to spend too much time with it. -1/2 x plus 5 over 2 is y, which is, well, in this case, f of x. So f of x is -1/2 x plus 5 over 2. F of x inverse, whatever. There's your answer. All right, did it a little quickly, but it's not any different than what we've been doing. Now, same thing. I'm just going to draw a table. So we have the inverse function that it gives us and f of x that we want. So what I want is the domain of f of x. That's what I want. But what I'm given is the domain of the inverse, which is -2, 7 with a bracket. I don't know its range. and I don't know the range of the regular f of x function. But remember, these work with each other, or they're not work with each other, they're the same thing. So I'm going to do what I've been doing this whole time. I'm going to plug this in for x into the inverse function, get my y's, that's my answer. So f inverse of -2, we have 5 minus 2 times -2, or 5 plus 4, which is 9. -2 has a parentheses, 9 gets a parentheses. Now f inverse of 7 is 5 minus 2 times 7, or 5 minus 14, which is -9. 7 has a bracket, -9 gets a bracket. So the range of the inverse is -9, 9. You put it in least to greatest order. So that means this range is the domain of f of x, which is the answer of -9, 9. There's your answer. It's the exact same thing. The notation changed, but notation doesn't really mean much. It's just how you call something. Same answer, same word, same everything. Well, not same answer, but same way to get the answer. All right, number 10, write an equation for g of x in terms of f of x if the graph f of x is horizontally stretched by a factor of 5/2. So I have that. Then reflected across the y-axis before it's translated 3 units up, resulting in a graph of g of x. Okay, so I have some f of x function. The first thing I did is I horizontally stretched it by a factor of 5/2. I'm not sure why I use the same color for each one. But right here, horizontally stretched by a factor of 5/2 means not h, but b. It's 5/2, which means when you put it into the equation, you have 1 over b, so you have f of 2/5. You flip it, right? 1 over 5/2 is just 2/5. So 2/5 x is what you have when you horizontally compress it. After that, reflected across the y-axis. Across the y-axis is a horizontal reflection. That's telling me b is -1. It doesn't matter if you flip it or not, because it's -1 over -1. If you flip it, it's still -1. That's what you have after you flip it. And then finally, translated 3 units up, resulting in the graph of g of x. So going 3 up just means your k is 3, add 3. So your final answer is g of x equals f of -2/5 x, all plus 3. Very similar to the one we did before, just that this one has the flipping of the b, so be careful with that. Again, remember it's in this form, a f of 1 over b, x minus h, all plus k. If I was you guys, when you get your test tomorrow, write this down right away with the transformation rule of bx plus h, comma ay plus k. These are very important. You need them all year. So when you honestly get your test, write it down right away so you don't blank on it during the test. You could have it memorized very well now, but come down to the test, you kind of blank out and you forget it. Number 11, another question just like the one we just did. So again, I have f of x. The first thing I do, or that I do to it, is reflect it across the y-axis. That again is a horizontal reflection. So you have f of -x, -x. After that, we vertically compress it by a factor of 3/7. Vertically means your a. So now we have 3/7 f of -x. Then it's translated 4 units up. So we add 4. And this thing is your answer. 3/7 f of -x, all plus 4. Let's just keep going. 12. The domain of f of x is -2814. Its range is -615. Using interval notation, write the domain and range of g of x if g of x are these transformations on f of x. So this is very similar to a quiz problem that a lot of people have trouble with. I get it. It can be a little confusing. But what you want to do is you want to kind of think, well, what is my domain? What is my range, right? So remember, your domain are just x's, and your range are just y's. So if f of x has a domain of 28, 14, and a range of negative 6, 15, that just means those are all your possible x's and all your possible y's. So remember, what we have is the transformation rule, bx plus h, ay plus k. What these do is they transform your original x's and y's, right? In this case, the f of x. It transforms the x's and y's of f of x and gives you your new x's and y's for g of x. And this is exactly how I would solve it. Because I want to find the domain and range of g of x. Well, g of x are these transformations on f of x. I'm just going to use my transformation rule to transform my old x's to my new ones and my old y's to my new ones. So if I look at the function, I can see that a is 2/3, b is negative 1/2. Remember, this negative 2 you flip. H is negative 8. You flip the sign. Remember, everything inside the parentheses, everything next to your x is going to act weird. So that's what I have. So if I fill out my transformation rule, what I have is negative 1/2 x minus 8 and 2/3 y minus 4. So all I need to do is take my x's, plug them into, that's an ugly star, but plug them into the bx plus h, my y's into this thing. So for negative 28, I have negative 1/2 times 28 minus 8, negative 14 minus 8, negative 22. All right, so that's one of my domain, my new domains. And 28 had a parentheses, negative 22 is getting a parentheses. All right. 2/3 f negative 1/2. The domain of that is, wait, give me a second. Oh, it's negative 28. Sorry, negative 28 minus 8. There we go. Let's do that one more time. Negative 1/2 times negative 28 is 14 minus 8. That is 6. That gets a parentheses because negative 28 got a parentheses. Now I'm going to do the same thing, but I'm going to use 14. Negative 1/2, 14 minus 8. Negative 7 minus 8 is negative 15. 14 has a bracket, negative 15 gets a bracket. All right. So my new domain is going to be from negative 15, because that's smaller, to positive 6 with a parentheses. And now I'm going to do the same thing for my y's. Just move this over here and do it in different colors so we don't get lost. So I have 2/3. I'm plugging this in. So negative 6 minus 4. That's negative 4 minus 4, which is negative 8. Negative 6 has a parentheses. Negative 8 gets a parentheses. That's what we have. Now we're doing it 15 as well. 2 or 3. 15 minus 4. That's 10 minus 4 is 6. 15 has a bracket. 6 gets a bracket. Order from least to greatest. Your new range is negative 8, 6. Just like that. And this right here is your answer. That's your new domain and new range. All right, write a function that gives g of x as a function on f of x. Get it in the tables below. All right, so for this one, all right, so remember for this, I want to figure out a, b, h, and k. All right, so it doesn't matter what you start with. Let's start with the x's. So remember, x's, you're going to look at your jumps between each point. So here I have plus 3, plus 3, plus 1, plus 2, plus 4, 2, and 3. And then my new distances between my points are plus 6, 6, 2, 4, 5, 8. That's 4 and 6. So what you want to do is compare the distances between the points. Because if you horizontally compress or stretch something, or stretch a graph, the distances between 2 points are either going to get closer when you compress it, or get further away when you stretch it. And that's what B tells you. It tells you your horizontal stretches and compressions. So I had 3, and then somehow I got to 6. So you can kind of think of it as I had a distance of 3. I stretched it by some b value to get 6. I start with f of x, you go to g of x. You started at 3, I got to 6, so b is 2. I can put that in. Next, I'm gonna look at my a's. You always want to do your multiplicative stuff first, or really do your a's and b's. That's gonna tell you your, that's the distance. So that's minus 9, minus 6. That's plus 3, plus 6. That's plenty. You can keep going if you want to. We can stop there. 3, 6, plus 3, plus 2, minus 1, minus 2. Same thing, pick whichever 2 you want. Let's go with negative 6 and 2. So what that says is I had negative 6, right? I had a distance of negative 6 between some points, and that negative 6 became a positive 2 somehow. I compressed it by some a, right? 6 is going to 2, I'm compressing it. I compressed it by some a, and I got 2 somehow. That means a is negative 1/3, right? Solve it for a is negative 1/3. So I have my a and my k, or my a and my b, sorry. And now I'm going to use my transformation rules. I have bx plus h, ay plus k. So if I use bx plus h, that transforms any of my original x's to my new ones. So my b is 2, so I now have 2 times some x value. It doesn't matter which one you choose. I'll use 1. 2, 1 plus an h, and this 1 transforms to negative 1. It doesn't matter which x you pick, but make sure you pick the right point it transforms into. So 2 plus h is negative 1, h is negative 3. All right, and then from here, same thing with the ay plus k, the other transformation rule. My a is negative 1/3 times y. So which y am I going to pick? Well, I'm going to be smart and pick one that's divisible by 3, but they're all divisible by 3, so it doesn't actually matter. We'll pick 3. I don't want to pick 0, it'll be too easy. So we'll pick 3 plus some k, but 3 transforms into 4. Make sure you pick the right one. Negative 1/3 times 3 is negative 1 plus k. Add it over. K is 5. So these are that's your a, b, h, and k. Whoops, wrong thing. All right. So that's my a. There we go. That's what I have. I'm gonna put it down here so we can work with it. So I want the formula. That's my a, b, h, and k. So remember, g of x is a f of 1 over b x minus h all plus k. So g of x is negative 1/3, f of 1 over b, so it's 1/2, x plus 3 all plus k, or whoops, plus 5. Okay. And that is your answer. All right, there's the work. Let's keep going. Use composition of functions to determine if functions f of x equals 3/2x minus 7 and g of x equals 2/3 x plus 7. So remember, what you need to solve is f of g of x is x, and also g of f of x needs to equal x. In other words, if you plug the functions into each other, they should equal each other. Actually, I'm going to pick different colors so you can kind of see what's happening. So f of g of x equals x. And at the same time, g of f of x equals x. So remember, like I'm going to do the first one first on the left. The green function, or the one on the outside, it's kind of like your base function where you base everything off of. So f of g of x is the function f of x 3/2, but instead of x, you put g of x. All of that minus 7. So solve this out, because I know what g of x is, I can plug it in. G of x is 2/3 x plus 7. And all of that minus 7. Distribute this in. These cancel out. You're left with x plus 21/2 minus 7. Well, that's x plus 21/2 minus 14/2, or x plus 7 over 2. That is not x, so I don't even need to do the other one to say that these are not inverses. All right, for practice, I would plug in this one, do them both, make sure you know how to do these because these can be a little tricky. All right, so see what I did, look at the notes, look at the video Ms. Springfield put up to know how to plug them into each other. Let's keep going. Here's the last, nope, not the last one. All right, so now this one, use the graph to the right to answer all the following. A, list all the relative maximum values. So relative max means you went up, then back down. So in this case, we have 6 right there. Remember, values means y. So my values are 6, that's 8, and that's it. List all the relative minimum values. That means you decrease and increase. That's going to be this one right here at that's 5, and right here at -6. All right. After here, or after that, the absolute maximum values. When we say the word absolute, that means I don't need for it to go up and back down. I just need the biggest y value in the whole graph. In that case, that's going to be 8. Absolute minimum, same thing. That does not need to decrease and increase again. I just need the smallest y value in the whole graph. And that's this one right here at -6. All right, so now my increasing and decreasing, let's erase these points and look at it. So where's the graph increasing? That means when you read a graph from left to right, that's how you always read graphs left to right. You want to see where my y is going up. So I'm increasing from here to here, right? This interval is going up, this interval is going up, and this interval is going up. So write that in terms of x, because if we say where, we're saying x. Where is increasing? From -9 to -6. From -3 to -2. And from 5 to 9. Now, where's the graph decreasing? I'm decreasing on these blue parts I'm going to draw, just those two. So where, again, is x? You have -6 and -3. And also -2 to 5. That's where I'm decreasing. Where I'm at positive, just go ahead and erase that. The graph is positive when you're above the x-axis. So everywhere I'm drawing right here in green, that's when I'm above the x-axis. So again, where is x? So where am I? Well, from -8, not including -8 because it's 0, all the way to 2, not including 2 because it's also on 0. And also from 7, not including 7 because it's 0, all the way to 9. But I am including 9 because when I stop at 9, I'm a positive value. Where's the graph negative? That's underneath it. It'll be this part and this part. So I'm negative from -9, right? This part right here, to -8, and also from 2 to 7. What is the domain of the graph? Remember domain, that's all the possible x's. If I look at it, my smallest x is -9 right here. My biggest is +9. It's inclusive because they're filled in circles. The range of the smallest y to the biggest. The smallest is -6. The biggest is 8. There's no breaks in between. It's part of the graph. They get brackets. Don't worry about that. Did that a little quickly, but that's how you do that. All right, we have 2 more problems. Let's do 16. Find the average rate of change of the function on the interval. So I'm going to do this a little quickly. Basically, these are your x's, x1 and x2. Plug these in. F of -2 is -2 times -2 squared plus 8 times -2 plus 5. This is 4, so you have -8 minus 16 plus 5. That's -24 plus 5 is -19. F of 4 is, -2 times 4 squared is 16 plus 32 plus 5. -32 plus 32 plus 5 is just 5. So I have the points -2, -19, and 4, 5. Average rate of change. Remember, y2 minus y1 over x2 minus x1. So 5 minus -19 over 4 minus -2. That's 24 all over 6, which is 4. And that's going to be your answer. That's your average rate of change. You need the y's, right? So this became x1, y1, x2, y2. Plug it into this formula, and you have your average rate of change. All right, so let's do number 17, last problem on the review. The graph of f of x is given to the right. Draw the graph of g of x on the same grid. So remember, anytime we're transforming points, we're going to use the transformation rule of bx plus h, ay plus k. So if I look at what I'm given here, let's finish on this problem. So this g of x, I know that a is 1/2, b is -1, h is -6 because x plus 6, k is -3. And I want to transform this graph, so I'm going to pick the important points on this graph. That one was -9, -3, -6, 3, -3, -1, -2, 1, and 2, -1. All right, that's what I have. And I want to transform these points. I listed out my a, b, h, and k, because what I'm going to do is plug them into bx plus h. So I have -x minus 6 and 1/2 y minus 3. I'm just going to plug in each one of these points right here into the transformation rule to get my new points. So my g of x points, I have -x minus 6. So for every single x value, so for like -9, -3, I have I have 9 minus 6, which is 3. And then for -3, you have -1/2 minus 3, which is -4.5. -6, -3, that gives you 6 minus 6, which is 0. Then 3 times 1/2 gives you 1.5. 1.5 minus 3 is -1.5. -3, 1. You have 3 minus 6 is -3. -1 gives you a -1/2. Minus 3 is -3.5. -2, 1. Plug in -2. You have 2 minus 6, which is -4. 1 times 1/2 is 1/2 minus 3, which is -2.5. And then finally 2, -1. -2 minus 6 is -8. -1 gives you -1/2 minus 3, which is -4.5. All right, so that's what you have. Just go ahead and graph it. I'll do it in blue. You have 3, -1.5, or -4.5. Right here. 0, -1.5. Right here. -3, -3.5. Right there. -4, -2.5. Right here. Then -8, -4.5. Right here. Connect it left to right so you get something that looks like that. Let me double check to make sure I didn't make a, kind of dumb mistake. Where's my key? Yep, looks like that's it. 2.5. Oh, yeah, this one. Graphed that wrong. I wrote it right, graphed it wrong. There we go. So -8, -4.5 right here, and -4, -2.5 right here, and -3, -2.5. Sorry, plotted some points wrong by accident. Anyway, that's what you get. That's it. Hopefully the video was helpful, guys. Don't forget to do the homework. The biggest thing to help you for the test tomorrow is always going to be homework. The questions are always based on homework and the notes. Hope this was helpful, guys. Good luck.